There's a substance on the moon that doesn't exist naturally anywhere on Earth. 3 atoms fused in starlight. China just brought some back. And when I learned what they plan to do with it, I realized we're not witnessing a space race. We're watching the quiet beginning of the energy revolution that will define your grandchildren's world. But here's what no one's telling you about the cost. I've spent the better part of my life trying to help people see what's right in front of them. A beetle navigating a forest floor, a whale singing across an ocean, the slow, relentless creep of ice ages, and the sudden, violent beauty of volcanic birth. I've always believed that if you can truly see something, really see it, you'll care about it. And if you care about it, you might just protect it. But what I'm about to share with you isn't happening in a rainforest or on a coral reef. It's happening 240,000 miles above your head, on a world with no atmosphere, no water, no life. And yet what's unfolding there will shape your life more profoundly than almost anything happening on Earth right now. You just don't know it yet. Most people still think of the moon as poetry, as that silver disk that pulls the tides and makes us feel small and wonder-filled when we look up on a clear night. We think of it as the place where astronauts planted flags 50 years ago, took a few photographs, hit some golf balls, and came home. We think of it as history, as something we did and moved on from, but we were wrong. The moon isn't history. It's becoming the future. And the reason has nothing to do with flags or footprints or national pride. It has everything to do with a substance that most people have never heard of, that sounds like science fiction, but that might just be the key to solving our energy crisis or starting the next great territorial conflict. Possibly both. You deserve to understand what's really happening. Not the sanitized version you see in headlines about billionaires and rockets. Not the romantic version about human exploration and the final frontier. The real version. The one where nations are quietly, methodically preparing to strip mine another world for a fuel that could change everything. And the one where you and I have to decide what we think about that while there's still time to have a voice in how it unfolds. Let me tell you what no one else is telling you clearly enough. Space isn't the final frontier anymore. It's becoming the next contested resource zone. And the battle isn't being fought with weapons. It's being fought with landing modules, with mining permits that don't quite exist yet, with international law that has enormous gaps, and with a fuel called helium-3 that sounds like something from a science fiction novel but is very, very real. You keep hearing about space races and billionaires launching rockets. You hear about Mars colonies and asteroid mining. And it all feels abstract, doesn't it? Like it's happening in some distant future that doesn't touch your life. You've got bills to pay, work to do, children to raise. Why should you care about what's happening on the moon? Here's why. Because the decisions being made right now about who can take what from the moon, about who profits, about what rules apply, about whether we bring wisdom or just hunger to our expansion into space, these decisions will determine what kind of energy your children have access to, what kind of world they inherit, and whether humanity learns anything at all from the mistakes we've made here on Earth. The myth is that space is neutral, a place of cooperation and scientific wonder. The reality is that space is becoming property, not officially, not legally in the traditional sense, but practically, functionally, and it's happening while most of us aren't paying attention. You deserve to understand this transformation, not because you need to become a space expert, but because you're a human being living through a pivotal moment, and you have the right to know what's being done in your name, in humanity's name. So, let me start with a story. Because facts are useful, but stories are how we actually understand things. And this story begins not with China, but with an American geologist named Harrison Schmitt. In December of 1972, Schmitt became one of only 12 humans to walk on the moon. He was part of Apollo 17, the final mission of the Apollo program. While the other astronauts were pilots, military men trained for precision and protocol, Schmitt was a scientist, a geologist, and he looked at the moon differently. To him, every rock told a story. Every crater was a page in a book, written over billions of years. On the third day of the mission, Schmidt was exploring the Taurus-Littrow Valley. He bent down and picked up a rock. It was unremarkable in many ways. Greyish, rough-textured, ancient. He didn't know it at the time, but that rock contained something extraordinary, something that would haunt him for the rest of his life. Years later, back on Earth, scientists analyzing samples from that mission discovered trace amounts of a substance embedded in the lunar rocks. Helium-3, an isotope of helium so rare on Earth that it barely exists. But on the Moon, it's everywhere, embedded in the dust by billions of years of solar wind washing over that airless surface. And here's what made it extraordinary. Helium-3, if we could harness it properly, could be the key to fusion power. Clean energy, no radioactive waste, no meltdown risk, no carbon émission, the kind of energy that could power civilization without destroying it. Schmidt saw it immediately. He spent the next decades of his life trying to convince anyone who would listen. He gave talks, he wrote papers, he testified before Congress. He said, look, we found the future and we left it behind. We walked on a world covered in fusion fuel and we came home and forgot about it. But no one listened. Not really. It was too expensive, people said. Too far away. Fusion power doesn't even work yet, not commercially. Why worry about fuel for a technology we don't have? Schmidt died in 2023. Before he passed, China had already launched its Chang'e 5 mission. They landed on the Moon, collected samples, and brought them back to Earth. Among those samples, carefully analyzed in laboratories in Beijing, were confirmed deposits of helium-3, proof of concept, evidence of abundance. China was listening. Even if America wasn't, there's something profoundly sad about being right too early, about seeing something precious and being unable to convince others of its value until it's almost too late. Schmidt lived that tragedy. He saw the future and watched his own country turn away from it, while another nation quietly, patiently prepared to claim it. But why? Why did it take so long for anyone to care? And why was it China, not America, who finally acted? To understand that, I need to take you to another story. A kind of parable, if you will. Imagine two villages, nestled in a valley, separated by a river. For generations, both villages have survived the brutal winters the same way by burning wood. They clear the forests around them, chop the trees, stack the logs, and when the snow comes, they burn through their stockpiles to stay warm. It's hard work. It's dirty. The smoke fills their lungs. The forests thin out year by year, but it's what they know. Now, in one of these villages, a small group of people begins to experiment with something different. They start trying to weave sunlight itself into warmth. It sounds absurd. It sounds impossible. They build strange contraptions, devices that look nothing like fireplaces. They fail over and over. Their neighbors mock them. You're wasting your time, they say. We've always burned wood. It works. It's real. Your sunlight weaving doesn't even exist yet. But the weavers keep working. They make small progress, incremental gains. They're not doing it because it's easy. They're doing it because they can see what their neighbors refuse to see. The forest is finite. One day, there will be no more trees. And on that day, the wood burners will freeze. Years pass, decades. The wood burners keep burning, the forest keeps shrinking. And then, one terrible winter, the last tree falls. The wood burners look around in panic. There's nothing left to burn. They turn to the weavers, desperate, angry, afraid. And the weavers, who have spent decades perfecting their craft, who are mocked and dismissed and called impractical, simply say, "We knew this was coming, that's why we prepared." Helium-3 is woven starlight. Fusion power is learning to weave it into energy. And the Moon is where the raw material has been waiting for 4 billion years. China is the village that started preparing while everyone else was still burning wood. But what is helium-3, really? Let me make it simple, because this isn't about chemistry. This is about understanding What changes when you discover a new kind of fuel? Helium is a gas. You know it from birthday balloons, from that funny voice you get when you inhale it, from blimps floating over stadiums. It's light. It's inert. It doesn't react with other elements. On Earth, we have two main types of helium atoms. Most of it is helium-4, which has 2 protons and 2 neutrons. But there's another version, much rarer. Helium-3 has 2 protons but only 1 neutron. That missing neutron changes everything. On Earth, helium-3 barely exists. Our atmosphere has traces of it, maybe a few hundred kilograms total in the entire world. The reason is simple. Helium-3 is so light that over billions of years it escaped Earth's gravity and drifted off into space. We had it once, at the very beginning, but we lost it. The Moon, though, has no atmosphere, no protective blanket. For 4 billion years, solar wind streams of charged particles flowing from the Sun has been washing over the lunar surface, embedding itself in the dust. And solar wind is rich in helium-3. Every grain of lunar dust, every handful of regolith contains tiny amounts of it. Tiny but measurable. Extractable? Scientists estimate there are over 1 million metric tons of helium-3 on the Moon. Just sitting there, waiting. Now why does that matter? Because helium-3, when fused with deuterium in a fusion reaction, produces enormous amounts of energy, clean energy. 1 ton of helium-3, roughly the weight of a small car, could produce the same amount of energy as 15,000 tons of oil. 15,000 tons, without the carbon emissions, without the radioactive waste that comes from traditional nuclear fission, without the risk of meltdown. This isn't theoretical. The physics works. The challenge has always been building the reactors that can sustain fusion reactions long enough to produce more energy than they consume. We're getting closer. China, America, the European Union, private companies, everyone's working on it. And when it happens, when fusion becomes commercially viable, the nation that controls the fuel supply will have an extraordinary advantage. This is why China moved first. Not because they're villains in some geopolitical drama, but because they looked ahead and saw what was coming. Let me be clear about something. China has an energy problem that most people in the West don't fully appreciate. 1.4 billion people, rapidly rising standards of living, massive industrial capacity. For decades, they've powered all of this with coal. Dirty, abundant, choking coal. They've become the world's largest emitter of carbon dioxide. Their cities are shrouded in smog. Their rivers run toxic. They know this. They know they can't continue this way. They've invested more in renewable energy than any other nation. Solar panels, wind farms, hydroelectric dams. But it's not enough. The numbers don't work. You cannot power a modern industrial civilization of that scale on wind and solar alone, not with current technology. The energy density isn't there, the storage solutions aren't there. Nuclear fission could help, and they're building reactors. But uranium is finite. Waste disposal is a nightmare. Accidents, however rare, are catastrophic. And most importantly, uranium is distributed unevenly across the world. You're still dependent on someone else's supply chain. Fusion changes the equation entirely. If you have helium-3 and you have working fusion reactors, you have energy independence. Forever. The sun will keep producing solar wind for billions of years. The moon will keep collecting it. The supply is functionally infinite. So China made a choice. While America privatized its space program, handing rockets over to billionaires like Elon Musk and Jeff Bezos, China nationalized its lunar ambition. They created the Chang'e program, named after the Chinese moon goddess, and they approached it with extraordinary patience. Chang'e 1, launched in 2007, was an orbiter. It mapped the moon. Chang'e 2 refined those maps. Chang'e 3 landed a rover. Chang'e 4 did something no one had done before. It landed on the far side of the moon, the side we never see from Earth. Chang'e 5, in 2020, brought back samples, 1.7 kilograms of lunar soil. Inside that soil, confirmed deposits of helium-3. Proof of concept. evidence that what they were planning was possible. And now they're building toward Chang'e 6, 7, and 8. These missions aren't just about science, they're about establishing infrastructure, testing mining equipment, building a permanent lunar research station. By 2030, they plan to have humans living on the moon. By 2040, they plan to begin extraction operations. This is not speculation. This is stated policy. Public plans backed by enormous investment. And here's what makes it so strange, so morally complex. The country that industrialized the fastest, that burned the most coal, that polluted the most aggressively to lift hundreds of millions out of poverty, is now trying to lead the clean energy revolution. The nation built on extraction is reaching for starlight. There's something almost poetic about that, and something deeply troubling, because while China is planning and building, the rest of the world is caught in an uncomfortable question. Who owns the moon? The answer, legally speaking, is nobody and everybody, and it's complicated. In 1967, at the height of the Cold War, the United Nations created the Outer Space Treaty. The United States, the Soviet Union, and dozens of other nations signed it. The core principle was simple and idealistic. Space, the treaty declared, is the province of all mankind. No nation can claim sovereignty over the moon or any celestial body. You can't plant a flag and call it yours. It was a beautiful idea. Space would be different. Space would be where humanity cooperated instead of competed, where we left our territorial instincts behind. But here's the problem. The treaty says you can't own the moon as territory. It doesn't say you can't take things from the moon. It doesn't say you can't extract resources and claim ownership of those resources once you've mined them. It's the legal equivalent of international waters. No one owns the ocean, but you can fish in it. You can drill for oil under it. You can take what you can reach, and once you've taken it, it's yours. The result is a gray zone, a legal void, and nature abhors a vacuum. So nations are filling that void with their own interpretations. In 2015, the United States passed the Space Act. It says that American companies have the right to own and sell resources they extract from asteroids and the moon. Luxembourg, a tiny European nation with big space ambitions, passed similar legislation. So did Japan, so did the United Arab Emirates. China hasn't passed a law like that. They don't need to. They're simply building the capability to extract resources, and they're assuming that possession will be 9/10 of the law, just like it's always been in human history. And that's what keeps me awake at night, because we're creating property rights faster than we're creating ethics. We're establishing extraction frameworks faster than we're asking whether we should. Every resource grab in human history has followed the same pattern. Someone discovers something valuable, people rush to claim it, laws get written after the fact to legitimize whoever got there first. Indigenous populations get displaced. Ecosystems get destroyed. Wealth concentrates in the hands of a few. And by the time anyone asks whether this was a good idea, it's too late. The thing is done. Gold rushes, oil booms, the scramble for Africa, the colonization of the Americas. Over and over, the same story. Discovery, exploitation, depletion, conflict, regret. The moon is our chance to write a different story. But only if we're willing to ask the hard questions now, before the mining equipment lands, before the first ton of helium-3 gets shipped back to Earth, before it becomes economically and politically impossible to stop. And those questions are uncomfortable. They should be. If China establishes a permanent base and begins mining operations, does that give them de facto ownership of that region? If an American company lands a robot and starts extracting resources, do they own what they take? What if two nations claim the same crater? What if private companies start competing for the richest deposits? Who mediates disputes? The UN? The International Court of Justice? Those institutions were designed for Earth, for nations with borders and treaties and centuries of legal precedent. They're not designed for the moon. And here's the deeper question. The moon is humanity's shared heritage. It's the first extraterrestrial object we ever walked on. It's been part of human consciousness for as long as we've had consciousness. Every culture on Earth has stories about the moon. Songs, myths, poetry. It's pulled our tides and lit our nights and made us wonder what else might be out there. Do we really want to industrialize it? Do we want the moon to look like an open pit mine? Because that's what we're talking about. Mining operations, excavation equipment, dust plumes, scarred landscapes. And because there's no atmosphere on the moon, no wind, no rain, no erosion, those scars will last forever. Literally, forever. The footprints the Apollo astronauts left in 1969 are still there, perfect, unchanged. If we strip mine the moon, those scars will outlast our civilization. They'll outlast our species. Billions of years from now, long after Earth has been consumed by the expanding sun, those scars will still be there. A testament to what we chose to do. Is that the legacy we want to leave? And then there's the practical problem, the one that rarely gets discussed. We're mining fuel for fusion reactors that don't exist yet. Not at commercial scale. We have experimental reactors. We have promising results. We're getting closer. But we're not there. So we're putting enormous resources into extracting helium-3 from the moon before we've proven we can actually use it efficiently. It's like building an enormous gasoline supply chain before you've invented the car. Maybe it makes sense as long-term planning, or maybe it's a colossal misallocation of resources. And what about the energy cost of extraction? You have to land equipment on the moon, you have to power that equipment, you have to heat the lunar regolith to release the helium-3, you have to compress and store it, you have to launch it back to Earth. Every single one of those steps requires energy, enormous amounts of energy. So the question becomes, does the energy we get from helium-3 fusion outweigh the energy we spend extracting it? We think so. The math suggests it does, by a lot. But we won't know for certain until we try. And by the time we find out, we'll have already committed to this path. We're so desperate for clean energy on Earth that we're willing to industrialize the moon. We're so afraid of resource wars here that we might start one up there. Let me take you to the future. 2045. It's not that far away. Some of you listening to this will still be alive. Your children almost certainly will be. There's a base on the moon. It sits in the Oceanus Procellarum, the ocean of storms, a vast plain of ancient lava flows. 37 people live there. They're not astronauts, not in the traditional sense. They're miners, engineers, technicians, doctors. They work in shifts. 6 months on the moon, 6 months back on Earth. The gravity is 1/6 of Earth's, so they have to exercise constantly to prevent bone loss and muscle atrophy. The radiation exposure is significant, so they live underground, in lava tubes and buried habitats. Their job is to extract helium-3. They deploy rover-like machines that scoop up lunar regolith, heat it in mobile furnaces to release the trapped gases, separate the helium-3 from everything else, compress it into containment vessels, and load those vessels onto return capsules that launch back to Earth every 3 months. One capsule contains enough helium-3 to power Tokyo for a year. A single city, 12 months, no carbon emissions, no radioactive waste. It's extraordinary. It's miraculous. It's exactly what we've been dreaming of. But the people in that base, looking up at Earth rising over the crater rim, that fragile blue marble hanging in the black, they wonder. They wonder if this is salvation or just another chapter in the same old story. They're saving Earth, maybe. But they're also extending Earth's addiction to endless consumption. They're enabling business as usual to continue instead of forcing humanity to reckon with the fundamental question, how much is enough? They watch cargo ships launch back to Earth, loaded with fuel, and they feel pride and they feel dread, both at once. Because they're part of something inevitable now, something that can't be stopped. The machinery is too big. The investment is too great. The need is too urgent. And late at night, in their bunks, they wonder if they're heroes or just workers in the latest extraction industry. The only difference being that this time there are no indigenous people to displace, no forests to clear cut, no rivers to poison, just an ancient, silent world that's been watching Earth for billions of years, and now it's being carved up for fuel. Is that better? Is that worse? Or is it just different? I don't know. I genuinely don't know. But I know we should be asking, so what do we do? What do you do as one person living on Earth, trying to pay your bills and raise your kids and live your life? How do you engage with something happening 240,000 miles away? Let me offer you something practical. Not because I have all the answers, but because I've learned that the antidote to despair is often just small, tangible action. First, educate yourself on what's actually happening, not just the headlines, the real details. Follow the missions, not just from one country, but from all of them. China's Chang'e program, America's Artemis program, India's Chandrayaan missions, Japan's Slimlander, the European Space Agency's plans, private companies like SpaceX and Blue Origin. Understand the Artemis Accords, which is the United States' attempt to create a framework for lunar cooperation. See who's signed them and who hasn't. Ask questions. Who's investing? Who's legislating? Who's being silent? And share what you learn, because most people still think the moon is untouchable, that it's just a symbol, that nothing real is happening there. You can change that. You can start conversations. You can make people see. You can't participate in a conversation you don't know is happening, and this conversation is defining the future. Second, reframe how you think about resources. Every time you hear the phrase natural resource, ask yourself, natural for whom? At what cost? Practice gratitude for energy. I know that sounds small, but try this. Tonight, when you turn on a light, stop for just a moment. Think about the chain of extraction behind that light. The coal mine, or the oil well, or the solar panel, the transmission lines, the infrastructure, the workers, the environmental cost. We've become so divorced from the source of our energy that we think it just appears magically when we flip a switch. It doesn't. It comes from somewhere. Someone paid a price. Now imagine a different world. Imagine if energy was abundant, truly abundant, clean, accessible to everyone. How would society change? Would we still have wars over oil? Would we still have energy poverty? Would we still be cooking the planet? Hold that vision, but also hold the tension. We need energy to survive. We need energy to thrive, but we're destroying ourselves to get it. Fusion could solve that. Or it could just be the next chapter in a long history of thinking technology will save us from having to change our behavior. Both things can be true. Third, demand ethical frameworks, not just technical ones. This is crucial. We're very good at asking how to do things. We're not as good at asking whether we should. Support organizations that are advocating for space governance, the Space Court Foundation, the Secure World Foundation. These groups are trying to create international legal structures that can handle the complexity of space resource extraction. They need visibility. They need support. Write to your representatives. Ask them, what is our country's position on lunar resource extraction? Do we have one? Should we? What role should the UN play? What protections should exist for celestial bodies? Most politicians don't think about this. It's not a hot-button issue. It doesn't win elections. But if enough people start asking, it becomes something they have to address. Engage with media critically. When you see a headline about space mining or lunar bases, don't just scroll past. Ask, who benefits from this? Who decides how this happens? Who's being excluded from the conversation? And teach young people. Teach them that space isn't neutral, that every frontier in human history has been shaped by who got there first and what they wanted. Space will be no different unless we actively make it different. The future isn't something that happens to you. It's something you build word by word, question by question, choice by choice. And fourth, this might sound strange, but hold the wonder. Don't let all the complexity and the politics and the ethics make you forget why we look up in the first place. Go outside tonight, find the moon, look at it, really look at it. Let yourself feel the strangeness of this moment. That ancient, luminous world that's been our companion for billions of years is now contested territory. It's now a mining site. It's now part of our economy. That should feel weird. It should feel significant. Let it practice both hope and grief. Hope that we might do this differently than we've done everything else. Grief that we've brought our old patterns to a new frontier. Both emotions are valid. Both are necessary. The moon has been watching us for so long, indifferent, patient, unchanging. It's seen everything. Our origins, our evolution, our first civilizations, our wars, our art, our love, our destruction, our brief, shining moments when we managed to reach beyond ourselves. And now it's watching us decide what to do next. Whatever we do to the moon, we do to ourselves. Because we're not separate from this. We never have been. The moon pulled the tides that shaped the shorelines where life first crawled onto land. The moon stabilized Earth's tilt, giving us seasons, making complex life possible. The moon has been part of our story since before there was a story. And now we're writing the next chapter, together, whether we know it or not. So here's what I want you to understand. When we started this conversation, the moon was probably just a distant curiosity to you, something poetic, something that belongs to poems and songs and childhood wonder, something that doesn't touch your daily life. But now you see it differently, don't you? You see it for what it's becoming, a mining site, a contested resource, the opening chapter of humanity's expansion beyond Earth. You understand now that helium-3 isn't just some obscure isotope. It's a mirror. It reflects everything we are, our brilliance and our short-sightedness, our hunger and our hope, our ability to reach for the stars and our tendency to repeat the same mistakes over and over. You've learned that China isn't acting out of villainy, they're acting out of long-term survival strategy. They looked ahead 50 years and saw an energy crisis coming, and they decided to prepare. That's not evil. That's actually rational. The question is whether we can build something more than just competing national interests, whether we can create actual cooperation. You've learned that the legal framework governing space is alarmingly thin, that we're making up the rules as we go, that property rights are being established faster than ethics, that we're about to do something unprecedented in human history, extract resources from another world, and we're doing it without really asking the hard questions first. You've learned that the energy crisis isn't just about solar panels and wind turbines. It's about whether we're willing to reach for something radically new, even if it means leaving Earth's surface behind, even if it means industrializing a world that's been pristine for billions of years. And here's what I hope you've really learned. You are not separate from this story. The moon isn't up there, it's in your orbit. Literally and metaphorically, what happens to it happens because of choices we make or fail to make. You're not powerless, you're simply late to a conversation that's been happening without you. But you're here now, you're listening now, you understand now, and that changes everything. Because the future isn't inevitable, it's not written. It's being written right now by people making choices, by nations making policy, by companies making investments, by citizens like you deciding whether to pay attention or not. We are not too late, we're not too small, we have always been a species that looks up, that wonders, that reaches. That's what makes us human, that's what's beautiful about us. The question was never whether we'd go back to the moon. Of course we would. The question is whether we'll bring our wisdom with us this time, whether we've learned anything from all the times we've discovered something precious and destroyed it in the taking. Whether we can look at a world full of fuel and ask not just how to extract it, but whether we should, and on what terms, and with what safeguards, and for whose benefit. I believe we can. I have to believe we can. Because the alternative is too grim to accept, but we can only do it if we choose to, if we engage, if we ask questions, if we demand better from our leaders and our companies and ourselves. So if this shifted something in you, if you see the moon differently tonight, if you feel the weight and the possibility of this moment, I want you to do something for me. Leave a comment. Tell me what surprised you. Tell me what worried you. Tell me what gave you hope. Tell me what you think we should do, because I want to know. I genuinely want to know what you're thinking, what you're feeling. This isn't a monologue, it's a conversation, and I need your voice in it. Subscribe if you want to keep exploring these questions together. if you want to keep pushing into uncomfortable, necessary, beautiful territory. If you want to be part of a community that doesn't look away from hard things and share this with someone who still thinks space is just for astronauts. Because it's not. It's for all of us. The decisions being made will affect all of us. And the more people who understand that, the better chance we have of shaping those decisions wisely. Look up tonight. That pale light filtering through your window has witnessed everything. Our origins, our struggles, our triumphs, our failures. The moon has been there for all of it. Patient, silent, luminous. And now it's asking us a question. What kind of species do you want to become? The kind that learns or the kind that repeats? The kind that cooperates or the kind that competes until there's nothing left to compete for? The kind that brings wisdom to new frontiers? Or the kind that brings the same old hunger, just to different places? The moon is listening, the future is listening, and so am I.